Yesterday we started the discussion on um, determinants. Determinant of a matrix. This is what our discussion was. We ended here. We discussed what is a minor. Um, so very first thing is we discussed that determinant of a number, just a single number, is the number itself. This is called the determinant of the first order.
Very
So
sorry to disturb, sir, but is this state board class?
who is speaking?
Sir, Kedar, sir.
Yes, Kedar. Your class will be at
Oh,
6:45.
sorry, sir. Sorry, sir.
Okay.
Sir, then actually I have a physics class today, right? So even tomorrow's Fridays and Thursdays class is clashing.
No, today is Wednesday, right?
Okay, okay. Yeah, okay, sir. Sorry.
I discussed it and fixed.
Sorry for disturbing, sir.
No, no problem. No problem.
Thank you, sir.
Thank you. Okay. So, determinant of matrix 1 by 1, that is only one element, is the number itself. Now, determinant of a square matrix of order 2, A, B, C, D, is AD minus BC. Okay. AD minus BC. So this is what we did yesterday. And then yeah. Now, actually, we have to go for a general definition of a determinant. General definition of a determinant. First, it is like, for that we have to understand minor. Now, minor of an element of a matrix is you remove the particular row and the column containing that element, and you get a submatrix. You get a submatrix, and you take determinant of that submatrix. That is the minor. Minor. So then yesterday we found minors like this. We removed the row and column of a particular element, row and column, and then we found the submatrix and found the determinant of the submatrix. Now, cofactor of an element of a matrix is cofactor of Aij is the minor of Aij multiplied with -1 to the power I plus j. So we took examples yesterday. We did in detail find the minors and the cofactors of all elements of A here. So minor of each element of the 9 elements we found, and then we said cofactors, how this -1 power I plus j, based on the location, how you get plus minus sign in a matrix. Uh, so this position Aij, this is A11, A12, A13, A21, A22, A23, this all. So each of these is associated with a sign as -1 power I plus j. So this is the minors. We have written minors of the corresponding elements here. And now you multiply with, plus, minus, plus, minus, plus, minus, plus, minus, plus. When we do that, you get the cofactors. So till here we discussed yesterday. Now, next is determinant of a square matrix, how is it defined? It is defined like this. It is along this determinant of a square matrix is defined as the sum of the products of the elements of the matrix and their corresponding cofactors taken along any row or any column. So we defined how a determinant can be along any row or any column. This is the matrix A1, B1, C1, A2, B2, C2, A3, B3, C3. And cofactors are capital A1, capital B1, capital C1, capital A2, capital B2, capital C2, capital A3, capital B3, capital C3. So element multiplied with their cofactors and then take the sum along any row or any column. So this is first row, A1 capital A1, B1 capital B1, C1 capital C1. Then second row, A2 capital A2, B2 capital B2, C2 capital C2. Then third row, A3 capital A3, B3 capital B3, C3 capital C3. Then we can do along any column also. We can do it along any column. So just a second. So along any column, when we do, see along the first column, A1, A2, A3. So A1 capital A1, A2 capital A2 plus A3 capital A3 sum. Second column, B1 capital B1 plus B2 capital B2 plus B3 capital B3. And third column, C1 capital C1, C2 capital C2, C3 capital C3. Okay. So now from here, we'll do some examples of finding determinants. Find the determinant of a matrix. Let us take a numerical value. I'll try to take a numerical value. Yeah. 1, 4, 2, 2, minus 1, 4, minus 3, 7, 6. So find the determinant of this. So now we can do along any row or any column. So the way to do it is like this. First I will do about first row. Okay, evaluating the determinant along first row. So let's say this is A. I'll write determinant of A. Now it is actually A1 plus B1 capital B1 C1 capital C1. This is what it is about the first row. Now you have to find the cofactors. Now cofactor, it is like this. So first element, that is A1 is 1 into minus 1 power I plus j. So into 1, that is. So you leave it as it is, into the minor. Remove the first row and the first column. You get -1476. Next, plus the second element 4 into cofactor of the second element. It will be associated with a minus sign, very important, minus of. Remove the row and the column, the first row and the second column. You are left with 2 4 minus 3 6. Then the third first row third element, first row third column element, 2 into. Now cofactor here will be associated, it is associated with positive sign, plus minus plus. So it is plus, remove the first row third column, 2 minus 1 minus 3 7. So the way, this intermediate step you can skip actually, if you know what you are doing. You can write this as 1 into, determinant of this is minus 1 into 6, that is minus 6, minus 7 4s 28. So minus 6 minus 28, AD minus BC. The second term will be negative, all right, and 4 times 2 6, 2 into 6 12, 2 times 6 is 12, and minus of 3 times 4 with a minus sign. So 12 minus of minus 12 plus 2 times 14, 2 sevens 14, minus of minus 3 into minus 1 is 3. So let us calculate this. This is minus 34 minus 24 times 4 plus 24 times 4 is 96, plus this is 11 2's 22. Okay, so you get some, yeah. So 96 minus 12. So that is minus 108. Now let us check the same. Let us check the same with some other row, some other column. Okay, I'm writing the matrix here for our ease. Let's say we do determinant evaluated along the first column. So alternative, this is, you can evaluate about any row or any column as long as you know the concept, how to do it. So determinant of A in this case will be first column elements. You don't have to write each time like this, you can directly evaluate, but because it's the first problem on determinants, I'm writing steps. So you have to evaluate about the first column. So first row first column element multiplied by the cofactor. Cofactor is -1476. Then the second um, first row second column is uh, you know, so sorry, second row first column is 2 multiplied by its cofactor. The cofactor will be with associated with a minus sign, and remove the first column and the second row, you get 4276. then plus the third row first column multiplied by the cofactor. Cofactor will be positive here. 4 2 minus 1 4. Now let's evaluate. It is 1 times, so minus 6 minus 28, minus of 2 times, minus 2 times 6 4 is 24, minus 7 2 is 14, minus 3 times 4 4 is 16, plus 2, minus of minus 2, plus 2 20. So this is minus 34, minus this is 10 times
20, sir.
2, 10 times 2 20, and this is 18 times 3.
54.
You get minus 108 again. Okay. So generally you should be practiced to write this step directly. All right. In both cases, instead of going like this. But of course, depends on your exam question. In the straight board, if it is asked for a long answer question, then you will have to write steps. If it's a short answer question, you can directly evaluate here and find the value.
Sir, determinant of a 4 by 4 matrix.
Good question. Determinant of a 4 by 4 matrix will be, it will be long because you have to evaluate 16 3 by 3, 16 determinants of 3 by 3 matrix. Okay, let us do one. I'll purposely put some zeros. So determinant A is 2 0 4 0. Purposely I'm putting zeros. Otherwise it will be very difficult to evaluate. And I'll purposely put the same matrix here. 1 4 2 2 minus 1 4 minus 3 7 6. That may also be make it long, but I'm just putting so that we have already evaluated it. 1 4 2 2 minus 1 4 minus 3 7 6. Okay, 4 by 4. And then I will add here 1 0 0. This will be easier. So find determinant of A. So advantage you have to see here. You should expand the determinant along the rows or columns which has maximum number of zeros. That will make it very fast, your calculation, because you don't have to calculate any other determinant. Now here there are 2 zeros in the first row and 2 zeros in the first column. So either you can evaluate about the first row or first column. Let us evaluate about the first row. Evaluating the determinant about the first row. Okay.
So in general, everyone will evaluate on the first row, right? Like if they don't mention anything.
Generally
Generally.
you will do, but intelligent solution is if there are so many zeros in one particular uh, row or column, then choose that row or column to evaluate. It will be much easier, fast. Okay, and there are many other
Will
properties also.
the board also accept that, like if we take Sure. Evaluate on any row or column.
Board will accept means as long as you get, see, as long as you mention what you are doing clearly and you get the correct answer, board will accept.
And determinant will be there will be same value you
Any
evaluate
row,
the
any
row
column.
or column.
Any row, any column you take, determinant will be the same.
Okay.
Okay. So this is what it is. Now first row you get uh, just a second. So first row, first column 2 times the determinant of the its cofactor. Cofactor will be associated with a positive sign and the determinant of the remaining elements. Remove the first row, first column, and this we have evaluated as minus 108. Now next we will see then plus 0 times minus of, so remove the first row and the second column, you will get 2 4 0 1 4 2 sorry, not 240. First row is gone. First row, see, I'll just do this. First row is eliminated, second column is eliminated. So you get 1 1 4 2 0 minus 1 4 0 7 6 plus 4 times cofactor here will have a positive sign. So what you have to do now, eliminate the first row and the third column. Then you are left with 1 1 2 0 2 4 0 minus 3 6 plus the last one 0 times, now you get a minus sign because minus 1 to the power, this is 1 4, right? 1 plus 4 is 5, so minus 1 power 5 will be minus, so associated with this term the cofactor will be negative. So I have to eliminate the first row and the fourth column. So I get determinant of 1 1 4 0 2 minus 1 0 minus 3 7. Okay, so now advantage of this is this you can directly write 0. Right now I have to explain to you the steps. I'm writing the determinant, but because you know this is 0 into some determinant of the cofactor will be 0. 0 into any cofactor will be 0. Now here this is 2 times minus 108 from the previous question. Otherwise you have to evaluate this. Plus 0 plus 4 times. Now we'll evaluate this determinant. Now advantage of evaluating. Now how will you evaluate this determinant? Evaluate about the first column because 1 0 0 is there. Don't evaluate about any row. Still you will get it, but this will be faster. So 1 times What is the cofactor? Eliminate this. Cofactor is 2, 4, minus 3, 6, right? So 2 into 6, 12. 2 into 6 is 12 minus of minus 12. Okay, plus 0. So this is minus 216 plus 4 times 24, 96. How much will this be? 120 minus 120. This is the value of the determinant. All right. So this is how we evaluate a determinant. So what do you do by 10 by 10 matrix determinant? You have to evaluate 100 9 by 9 cofactors and then multiply with the coefficients. Now how do you evaluate that 9 by 9 determinants? So you will have to evaluate 81, 9 into 9, 81 cofactors. So therefore you cannot do this problem just by hand. As up to 4 you can do it, and if you have a lot of time you can do up to 5 also, but even 4 will be difficult unless it has zeros in it. So we necessarily use a computer program, and computer program can calculate it very easily. All right, the huge matrices, it can find determinants very easily in a fraction of a second. So once you learn coding, how to code to find determinants, there are codes written, and so numerical computation in mathematics is very useful topic. I'll sometime when I do inverses, I will demonstrate it. So this is how you find determinants. Next, once you get the concept, I want you to practice problems. I have purposely left out the example questions from the textbook. So you do the example problems and simple problems you can solve from the exercise. Now, determinants can be very easily calculated using properties. There are certain properties of determinants. Properties of determinants. Okay, the mm, first one is, if a row or a column has all zeros in a square matrix, then the determinant will be 0. Obviously, okay, this is very clearly understood. Suppose this whole row in the previous one was 0 0 0 0. You expand about that particular row, 0 times cofactor 0. So when all rows are 0, then um, any all elements of any particular row is 0, then the determinant will be 0. You don't have to evaluate, just see and put 0. Now um, very important, if this is very important, if any two adjacent rows or columns of a square matrix. I'll not keep repeating square matrix. That is, we are understood that we are dealing with square matrices only. If any two adjacent rows and columns of a square matrix are interchanged, then the sign of the determinant changes by -1. Okay, if it's positive it will get negative, while without affecting the numerical value. Very simple. The logic is very simple. You see here, see this. Suppose I interchange. Suppose I interchange first row and second row. Now, and let's say I expand about the second row, not the first row. When I expand about the second row, the elements will be the same, 2 0 4 0. This comes to second row, this second row goes to first row. Now, instead of evaluating about the first row, I'll evaluate about the second row. So you will get 2040 intact. About 2040, when I expand, minors will be the same, but cofactors, because of the position here, position is, this is second row, first column, A21. So minus 1 to the power I plus j. Here you will have minus plus minus plus. Earlier signs associated were plus minus plus minus. Now it is reverse, minus plus minus plus, minus plus minus plus. So you get complete multiplication with a negative sign. So same value you will get with a minus sign. Okay, this is a very, very important. So now this is third one. If each element of a row or a column is multiplied by a number k, then the determinant value becomes k times the original determinant. So look at this. Suppose I have this A1, B1, C1, A2, B2, C2, A3, B3, C3. Now let us say I multiply the second column with k. You can choose any row, any column. I'm just choosing this one. You can, this is same as k times A1, B1, C1, A2, B2, C2, A3, B3, C3. Why? Because you expand about the second column. Cofactors remain the same, just that B1, B2, B3 are multiplied with k. So you will get k. It's common logic. It's a very simple logic. It's not a difficult one. Similarly, k A1, k A2, K A3. I'm taking the first, I'm taking the first row, K B1, K C1, A2, B2, C2, A3, B3, C3. This will be equal to K times determinant of A1, B1, C1, A2, B2, C2, and A3, B3, C3. All right. Next. So that similarly, if you multiply, go look reverse. If you multiply K to a determinant, now K can be multiplied throughout one particular row or one particular column. In matrix, it is not like that. Remember, remember, note, precautionary note. For a matrix, K times a matrix Aij will be equal to matrix K times Aij. Okay, that means if this was a matrix, K times, suppose this was a matrix, A1, B1, C1, not a determinant, it's a matrix.
Then it will be multiplied all over. I mean,
Yes. So don't get confused with multiplication of determinants and matrix.
so you, sir, you mean that in determinants it will only be multiplied to the factor we chose, right?
No, it will be multiplied only along one particular row or one particular column.
Okay, sir. Okay.
Okay?
So once we scroll up a little bit.
Yeah? Is this okay?
Yes, sir, just 1 minute, sir.
Hmm.
So done, sir.
So based on this is the next property, fourth property. Property 4, based on this, what it says is determinant of K times matrix A will be equal to, now depends on the order, n by n, let's say, then this will be K power n times determinant of matrix A. All right, where n is the order of the matrix. So same example here. So this one, I'll just, so now let us say this is, we are finding determinant of this matrix. I should, I'll do one thing. I'll take this whole, now I want to find determinant of this. So determinant of K times this matrix, all right, will be determinant of this. Now from each row you can pull out K, K from the first row, K from the second row, K from the third row. You will get K cube times A1, B1, C1. A2, B2, C2, and A3, B3, C3. Okay, it will be K cube times this. All right, clear? Next. So that's a trick about multiplication with, yeah, with the determinant. Now, next one, if any two rows or columns, if any two rows or any two columns of a matrix are equal, are identical, then the determinant is 0. Very, very useful property. Very useful property. The reason is very simple, because the cofactors, example, determinant of A1, B1, C1, A2, B2, C2, and A2, B2, C2. Same, they are identical rows. Now what happens when you do the cofactor? You will get A1 times B2, C2, B2, C2 minus B1 times A2, C2, A2, C2 plus C1 times A2, B2, A2, B2. So what you get is, because of identical rows, the cofactors will be 0. All right. For any determinant, this property is valid. As long as you have a two rows or two columns identical, blank, just blank, you just put the determinant as 0. Okay, this is a very useful property. Now extension of this property. Extension of this property is, if now if two rows, or if elements of any two rows or columns are of the same ratio, then determinant is 0. In other words, we can also say this, the same statement is, if a row or a column is a multiple of another row or another column, then the determinant is 0. So these properties we can use as a trick to evaluate the determinant very fast. So let us say you have same problem as the previous one, A1, B1, C1, A2, B2, C2, A2, B2, C2, but you have this as K, K, K. This will be same as K times A1, B1, C1, A2, B2, C2, A2, B2, C2. Because these two rows are identical, you will get K times 0, which is 0, using the previous property. So you have combined two properties here. One is this identical rows or columns. Another one is this property 3. Elements of a row is multiplied by K, then the whole determinant is multiplied by K. Okay. All right. Next. Okay, next property is this. I will not write the text of the property. This is the property. If the determinant of say a1 plus x1, a2 plus x2, a3 plus x3, b1 c1, b2 c2, b3 c3. This determinant will be equal to determinant of a1 b1 c1, a2 b2 c2, a3 b3 c3 plus determinant of x1 b1 c1, x2 b2 c2, x3 b3 c3. Very important, because what happens? Remember, it is not applicable if two columns are this is here one column. This is applicable to row also, not just column. If a particular column is sum of two elements, then we take the determinant. This is equal to the determinant of the first, taking the first element in the first column and the second element in the second column in another determinant, keeping the other elements the same. This is logically very simple. If you want to expand this, you will write a1 plus x1 times the cofactor of that first a1, then a2 plus x2, then cofactor multiplied by cofactor, a3 plus x3 multiplied by the cofactor of that position. All right. So now you can split this as a1 capital A1, a2 capital A2, a3 capital A3 plus x1 capital A1, x2 capital A2 plus x3 capital A3. Okay. So this becomes the first determinant. This becomes the second determinant. Understand? This is LHS. This is the RHS. Now suppose there are two rows, two columns. Two columns or two rows. I will illustrate this, otherwise you'll get confused. Note. Very special note. Now I will do for row wise. You just see this. A1 plus x1, b1 plus a1 b1, right? y1, sorry, then c1 plus z1. Now a2 plus x2, b2 plus y2, c2 plus z2, and you have a3, b3, c3. Now what you have to do is you have to expand one at a time. You will get 4 terms now. You will get a1, then a2 plus x2 remains as it is, b1, b2 plus y2, c1, c2 plus z2, a3, b3, c3 plus you get mm, x1, y1, z1, a2 plus x2, b2 plus y2, c2 plus z2, a3, b3, c3. Now you will have to split this into 2 and split this into 2. So you get 4 terms basically. You get a1, b1, c1, a2, b2, c2, a3, b3, c3 plus a1, b1, c1. You see here x2, y2, z2, x2, y2, z2, a3, b3, c3 plus. Now split this into 2. x1, y1, z1, a2, b2, c2, a3, b3, c3 and this one x1, y1, z1, x2, y2, z2, a3, b3, c3. Okay, so you have to do one row or one row at a time or one column at a time, depends on the problem. So this will split into 4, not into 2. So be very careful. These properties are very important, but you have to delicately apply. You cannot make mistakes in that. Okay, next. This is an important one. If very important property, if each element of a row or a column is multiplied by a number k and added to corresponding elements of another row or column, then the resultant determinant is 0. Okay, so let us say sorry, it's not 0. Sorry, it is sorry, it's not 0. If the original determinant is 0, then the resultant determinant value is equal to the original determinant. So what it means is like this. So I have A1, B1, C1, and to A2, B2, C2, I use A2 plus K times A1, B2 plus K times B1, C2 plus K times C1. So what is the example here? The example here is that to the second row, I have added the kth multiple of the first row. I have multiplied the first row by k. I have multiplied the first row by k and added to the second row. If this is the determinant, then this will be equal to, now based on the previous property, you can split A1, B1, C1, A2, B2, C2, A3, B3, C3 plus A1, B1, C1, K times A1, K times B1, K times C1, and A3, B3, C3. Now the second determinant is 0. We know it. They are of the same ratio. You can pull out k outside. You will get first row and second row identical. So this determinant will be 0. So you are left with A1, B1, C1, A2, B2, C2, A3, B3, C3. So the reverse logic also works. If to a particular row you add another row multiplied with some k times, the determinant value will not change. Determinant value will not change. Next, another, we'll stop with this one today. This is another very important property. The sum of the products of the elements of a row or a column with the cofactors of corresponding elements of another row or column is 0. Okay, this is matrix A. A1, B1, C1, A2, B2, C2, A3, B3, C3. Now, cofactors of A. Cofactor matrix I'm writing. So, all cofactors, cofactor of A1 is capital A1, B1, C1, A2, B2, C2, A3, B3, C3. So there's a very important property. Det A, we know you can choose any row, any column. The element multiplied by its own cofactors. This is determinant. Okay. About any column also you can choose, doesn't matter. This is what is the definition of determinant, right? All combinations are there. All right, 6 combinations. However, if I take A1 multiplied by cofactor of A2, then B1 multiplied by cofactor of B2, and C1 multiplied by cofactor of C2. So what I'm doing, first row multiplied by cofactors of second row, it will be 0. Or A2 multiplied by cofactor of A1, B2 multiplied by cofactor of B1, C2 multiplied by cofactor of C1 is 0. Or take the row, first row and the cofactors of the um, third row. Again, remember, this has to be done along row. Row means with rows, cofactors of second row. This is first row into cofactor of second row. This is first row, second row, cofactors of first row. This is first row, cofactors of third row. You can do for columns also. Second column, and cofactors of the third column. Second column multiplied by cofactors of the third column. This will also be 0. Okay, so we'll stop here. There are a few more properties. Once these properties are done, then we can solve problems. These are important properties and determinants. So 9 properties, for a few more are there. On next class on matrices and determinants will be on Monday. So coming 2 days, third day is Deepavali. We will not have a class on Deepavali day. But the coming 2 days, today, tomorrow and day after, I will start coordinate geometry for the students who have joined late. Coordinate systems and straight lines.
Sir, at the same time, right?
At the same time, exactly at the same time.
Sir?
Yeah, and for others, those who have already, you will not have class. If you are welcome to join, if you want to recap what we have done, you're welcome to join, but it's not necessary. If you feel that you are didn't grasp the concept at that time, you're welcome to join. For others, but those who have not attended the classes in August and September, they must join. It's a must. Yes, any other question?